here it is. This is the standard secant graph, and I know you're thinking maybe it looks a little bit crazy. We got asymptotes and these paraboloid-looking things everywhere. What is going on? And what I want to tell you is all the wonderful talking we did about zeros and asymptotes and infinities are going to make this make perfect sense, because what we are also walking into this with is the idea that secant and cosine are in fact reciprocal. So let me tell you how we get a graph like this using all the information that we already know about how to graph a cosine function, and then we'll go through and do like one step by step by step. But here's the deal. Let me get rid of this. Let me show you this other thing first. Here's our standard cosine graph. Yeah, everyone sees this. So we know a standard cosine graph has a period from 0 to 2 pi. Anytime we graph these functions, we're interested in where they have their maximum values and their minimum values and their zeros. And we're getting familiar with this, so we know cosine goes up 1, and then pi over 2 is 0, and then negative 1, whatever. We also know that secant and cosine are reciprocals. It's one over the other. So if we want to figure out what a secant graph looks like, and we know it's like 1 divided by cosine, the first thing we want to figure out is, where do I end up dividing by 0? Where is the cosine equal to 0? And that's what all these places are. All the places where the cosine graph would be 0 are places where the secant will be 1 over 0. They're going to be places where we can't let the graph touch. We're going to have vertical asymptotes there. So that's the first thing. If we're going to graph a secant graph, we would start by looking at a cosine graph and looking at where it's 0. And every place cosine is 0, we're going to go ahead, instead of draw 0, we're going to put a nice big fat vertical asymptote. So the next thing to figure out, let me make this cosine graph dotted line, because now we're just using this as a guide for us. Hold up. Is, everything else. So here's the deal. If cosine is reciprocal of secant, the closer I get to pi over 2, we can see the smaller and smaller the value of cosine is getting. So right here, the value of cosine is very tiny, which means it's reciprocal. 1 over tiny is very, very big and very, very positive. Same thing on this side. As I approach negative pi over 2 from this side of the asymptote, it's very, very tiny, but it's also positive. So the secant, the reciprocal of very, very tiny and positive, is very, 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 very huge. On the other hand, in this area, the reciprocal, this cosine value is very, very tiny and very, very negative. So its reciprocal is going to be hugely negative. And that's how we're getting these crazy U-shaped things. My secant graph that I started off with, every place cosine is 1, secant is reciprocal of 1. Guess what? The reciprocal of 1 is 1. So they're going to have those same points at 1. Everywhere cosine was 1 or negative 1, secant also is 1 or negative 1. Any place cosine was 0, secant is going to be having a vertical asymptote. And if the cosine part of the function were positive, then the secant is going to approach those positive infinities. If the cosine part were negative, the secant will hit those negative infinities. Let me put that cosine back in there to show you. Every place cosine is positive, the reciprocal is positive, and as that cosine gets smaller and closer to 0, the secant gets closer and closer to infinity. So to graph a secant function, we're going to follow all the same steps we did to follow cosine, but where they put zeros for cosine, we'll put asymptotes. The ones and negative ones will stay in place, and then we'll have these like things that approach the asymptotes. In the next video, I'm going to do one from scratch, and it's all the same information for sine and cosecant. So I don't think I need to make another video like this to talk about that, but we'll do one of those too. So I hope that makes sense, and let's see how this goes.